Hello. Hello and welcome.
Hello.
My name is Anastasia Bektimirova, and I'm a senior policy advisor at the Royal Academy of Engineering, which is just like the British Academy is another national academy right next door. And in my work, I focus on the policy environment around the digital and physical infrastructure that's needed to ensure that AI-enabled products and services can be developed and adopted for the benefit of the public and places. And I'm a social scientist by training myself, by the way. Today, I'm really delighted to have this opportunity to chair the panel called Scaling Impact, Computational Social Science in the Age of AI. And I'm going to start by saying just a few introductory words, just to set the scene a little bit. Welcome, please take a seat. So computational social science is a family of approaches that are data-intensive and that use methods such as modeling, network analysis, and quantitative text analysis, and many other ones to study the social, political, and economic systems. And those approaches, they go back decades, and in particular around the 2000s there was an acceleration. But what feels new perhaps is the AI and machine learning layer, which is expanding what we can study, model, and test. And today's conversation, it feels very timely because there is so much activity and attention to the so-called AI for science agenda. But most of it is focused mainly on STEM disciplines. So today really is an opportunity to spotlight the innovative social science work that's already happening and what it would take for social sciences to play the AI moment well. And so today I'm delighted to be joined here by the three wonderful panelists. So we have Hannah Claus, who is a Cambridge Gates PhD researcher, and she's specifically at the Language Technology Lab at the University of Cambridge. Then we have Sasha Vezhnevets, who is a staff research scientist at Google DeepMind, and we have Professor Ben Ansell, who is a professor of comparative democratic institutions at the University of Oxford. So thank you very much for taking the time to join us today. We'll start with a series of questions to the panel, and then we're going to spend the final 10 minutes by taking questions from the audience. So while you're listening, please ensure that you have some questions ready. So to begin, computational methods are very often framed as revolutionary for the social sciences. So to kick us off, could each of you perhaps tell us, based on your own work and also perhaps what you are seeing around yourselves, what it is that you can do today that was not as easily feasible or perhaps even impossible with other methods, and perhaps what do machine learning-driven methods and AI-based tools are adding in particular. And Ben, I'm going to turn to you first with this.
I'm just going to move myself back so I'm not positioned in a slightly odd way. So I run the Centre for Advanced Social Science Methods at Oxford, where we are in the process of hiring lots of people who work in this area. So obviously I'm on the lookout for very smart people. What are the types of things that we do across the social sciences with artificial intelligence that we couldn't do before? So I think there are three things. The first is that we can use artificial intelligence as a really good research assistant. We can use it to code and enumerate and annotate data at speeds that we couldn't previously do, with levels of accuracy that are much higher than they were 6 months ago, a year and a half ago. I really do think that's been the area where you do see the most usage. There's a slight risk to that, which is how do we train our own future replacement faculty, many of whom learn these skills as a research assistant. And that, of course, is a general issue with artificial intelligence and career ladders, that it often replaces kind of entry-level positions. The second thing that we can do is we can use artificial intelligence methods to fill in surveys, so to sort of mimic the types of responses that we might want to get. So I'll give you an example of a couple of colleagues of mine at Oxford, or were at Oxford, Ray Dutch and Roberta Serena. What they have done is they take the whole corpus of various social media sites. They did mostly use X in 2024. And what they try and do is look at how people are updating their social media opinions and assign those people to different demographic categories to then try and simulate how those people's opinions about the presidential candidates might be changing and use them as proxies for what you would normally do in a survey. So in other words, rather than going out and surveying people, you're trying to simulate a survey from doing this. And they got pretty close. Their estimates were probably better than the polls on average for the final result. The third thing you can do is you can get AI agents to do things to one another. So you can get them to play games with one another. So if you have heard of game theoretical approaches where you're trying to model how humans strategically interact with one another, if you've seen the film A Beautiful Mind, you will recall the scene in the bar where John Nash tries to explain the prisoner's dilemma with some complicated thing involving trying to buy drinks for a girl at a bar. Rather than engaging in these thought experiments, we can ask LLMs to act as if they were humans in, or some form of agent, in particular strategic situations. And so you can get what's called emergent behavior from that, behavior that comes, that isn't something that's reducible to a simple equation that you can't predict beforehand, but emerges from the process. So there we're trying to not just simulate sort of attitudes like a survey, but simulate behaviors. I will note that there's one slight danger with this that people have found, which is that those AI agents are not real automatons. They are scraping, if you like, how to behave like a human from the whole corpus of literature on the internet about how to behave like a human, including previous tests of what types of behavior might emerge. So this is the equivalent to something economists have found, which is that when they run experiments on economics students, they discover that economics students behave exactly like economics textbooks want them to behave. But that's because they've told the students to behave in that way. So there are some interesting challenges we're going to have to face in that we want to treat these like automatons, like automatic entities that do things, but they're not quite that. That's not quite what a large language model actually does. All right, I'll stop there.
Fascinating. Thank you, Ben. And Sasha, may I turn to you next?
I think Sasha. I work at DeepMind for the last 10, almost 11 years. And so my background is actually in reinforcement learning, which is how to get machines to behave. And until recently, the only way we could describe or elicit behavior in the machine is by providing a scalar quantitative reward. It's basically like training a dog. Whenever it does, if anyone ever trained a dog, it works basically like that. Whenever it does the thing that you want, you give it a treat and sort of recite the command. We don't do that like that. If you ever taught anyone, if you mentored anyone, you rarely just give them a piece of chocolate whenever they did the right thing. You just expect, like, wait until they do something right to reward them. So that was a very different paradigm, and we tried to use sort of reinforcement learning also to model social processes in some sense, and we had some limited success, but it was really clear these agents, they can't talk to each other. They don't, like, it's something, they're quite alien in a way, and they always start from scratch. What has really changed with the appearance of foundation models, and it includes large language models, but vision and action can all be part of that, is that it is, these entities, they're basically culture trapped in the weights of a neural network, and they are off culture. So we can now describe behavior in a very different way. For example, we can use like Martin Olson's logic of appropriateness. We can say, well, ask yourself what kind of person are you? Ask yourself what kind of situation is this? And then what would a person such as that do in a situation such as this and produce a behavior. And this is a lot more like we behave. I didn't have to give you a reward for sitting down on a chair, and you know exactly what to do when you're an audience or when you're a speaker. And we realized that there is opportunity, well, on one hand, to create agents that behave and learn and sort of react to the social circumstances in a different way, but also to model humans that way. And and I think Ben mentioned a lot of ways that, that this could be done. And I think one of the major challenges here is to understand what are our epistemic norms now, right? So if I ran the experiment with some sort of game theoretic underlying structure, and I get the result, how do I know it is actually valid? And I think we will pretty much have to establish the epistemic norms in every specific case. And be probably learning from the machine learning literature, where we clearly separate where did we train on, where did we validate our results on, and then when we're making a forecast, then that would be valid if it's there. And I will just give an example of a paper that's not from our group, it's from University of Chicago. They did a great work that's really inspirational. I think they took pre-COVID trained LLMs, made them politically affiliated in America, like you're a Republican and so on. And then they exposed them to COVID information, and then they asked them on different issues how would they behave, and asked for the reasoning of why. And they found that it matched quite a bit the actual response. And here there's both the methodology but also the validation, right? So you have the checkpoint until which you trained, have until now between that checkpoint where you can validate that. And now you can, with some certainty, say, well, if I have a public health problem, I probably can predict something about that.
Thank you, Sasha. And Hannah, what about you?
Thank you. Hi, everyone. It's great to be here. So just to give you a bit about my background, I work on large language models for underrepresented languages, which means that, you know, when you try ChatGPT, and it works really well in English, and then you go into literally any other language, and suddenly it doesn't work well anymore. And I think that's something that most people that are not native English speakers can identify with, when suddenly they use this technology in their own language and the words don't make sense or the sentences don't make sense. And that's what I keep looking at. And I work closely with different local communities to make sure that these technologies now work for them as well. And I think what we can now see, the change, that it has become so much better for local communities to actually build their own technologies as well. So the accessibility of building technologies, of actually, you know, seeing, does it work for me? Does it not work for me? And giving the right to the people to build it themselves has become so much easier. And I just see that, for example, in my work, I work with a community in Nepal, and their language is completely oral, so just spoken. They don't even have an orthography. And how would it be possible for such a community to preserve their language and their culture, but also access technology? And we've made it so much easier, because now it's not just about capturing textual data. We have, you know, images, videos, and so on that can actually, you know, create a broader sense of what this community is and how they can survive in this age. And I think with this, we've made technology so much more accessible, but we also have to make sure that it becomes even better, because even though it seems like everyone's using it, like not everyone's using it, you know. Right now we're still forcing everyone to learn English in order to access technology, to access these kinds of, you know, little nice things that we've built, but actually, you know, it's the majority of the world does not speak English. And I think we have to make sure that we use these things for good and for the communities, and actually work together with the communities.
Fantastic. Truly fantastic expertise on the panel, and I look forward to diving into some of these more niche areas. But perhaps when we think about the social sciences, people usually picture universities. But that is definitely not the only place where social science is happening. And I'm looking at you, Sasha, here, in particular, and the work that Google DeepMind is doing. So what is it that you are doing with the social sciences at Google DeepMind, and perhaps even comparable organizations as well? What use cases for social science are you finding?
So, kind of riffing on what we all said before, we really have a new type of agentic entities that are a lot more like us. I think before AI models, reinforcement learning, and so on, they were quite alien. They were like a different species from another planet in some sense. But now what we created is very much of culture. It's like a piece of culture, right? So to actually understand how it works, we now need to start understanding how the culture works. And specifically, as we're integrating AI, and especially agentic AI, further into our social structures, and that's what technological deployment is. If your technology didn't integrate into social structure, then you're basically keeping it in the basement somewhere, right? WhatsApp was impactful because it changed the way we do things. Canalization was impactful because we do things differently now that it's available, right? So similarly now, when we want to understand how to make the agents efficient, how to integrate them more into organizations, we have to kind of go now to the social sciences questions and read up on that literature with the help of the AI or without, and to understand sort of how those things work. And I think there is the growing understanding of that. In the part of DeepMind that I am, we're really interested in looking at the impact of technological deployment at the society, especially if you start thinking about things like AGI, how will that impact? And I think as an AI company, our strength is in building AI models, and we think that that could be the way for us to sort of simulate the social process and to be able to simulate the impact and try to guide it into a better place, and sort of to see how the equilibrium of our behavior will change once we introduce those entities. And I think there's also a lot of reconceptualization of what we have been doing in the context of social science. So I think there's so many companies now, like if you go like little startups that are doing exactly like modeling, like simulating a human. Oh, do you want a synthetic user base? Here you go, like we will create you one. And I think as these kind of companies in the advance, there will be more and more sort of interest in actually reading up on the social sciences, what they have to be said. And I think especially once we move away from this sort of solipsistic one agent doing a task view, but more into the sort of the emergent behavior, what happens when there is a group, what happens where there's a group of different incentives and the incentives are misaligned, how do the norms are supposed to be working, and so on.
Thank you. Very interesting. And moving on, a lot of the computational social science work is based on just digital trace data, so large-scale data sets that can underrepresent or mischaracterize some groups, some communities. So what are the most promising ways you've seen to bring in knowledge and perspectives that don't neatly fit into those data sets, whether that's through qualitative work or community expertise or anything else? What's your view on this? And I'll turn to you, Hannah, first with this.
Thank you. I mean, what I've seen so far is that we're trying to do our best, I think, but we're not getting there enough. I think there's so much money that people are almost throwing at AI and building new things, but I think this money is not equally distributed, where we could really invest in local communities around the world and make sure that they get to build their own things, because we have over 7,000 languages in the world that are actively spoken, and 50% of the internet is in English. So that just gives you a scale of how much influence English as a language, but also the culture that is associated with it, has on how we build these technologies. And if we actually looked into the infrastructure that is built beyond it, even if you train language models, they're all based on English. So all the data that you then evaluate it with is again in English. So really we have to make sure that now we start talking to researchers around the world, that we make sure that they're part of the conversation, that they have a seat at the table as well, because they will think of problems and solutions that we just don't have here because we don't have the same problems, right? So I think I would be ignorant to just assume that I know everything already. And I think it's very important that as researchers, especially in the computational space as well, we sit down with people outside of our expertise and make sure that we can have conversations together. Because my background was fully in AI. I studied computer science and robotics as well. And I realized that throughout all my studies, no one ever mentioned humans. No one ever mentioned the impact these technologies have on different societies. And, we only go from, okay, how do you build an app, and to how do you deploy it? But what happens afterwards, no one talks about. And I think that's something that we have to change in our thinking, and also that the people that will develop these technologies in the future have this kind of skill set as well, because we need to make sure that they incorporate humans in the way they build technologies, because we're, in the end, the people that have to use it, right? And if it's not built for us, how are we going to use it? So I think there's a lot of work that we still have to do, but the first step is really just opening our eyes to what is going on and the fact that we're not including everyone in this conversation.
Thank you. And what about you, Ben, Sasha? I'm sure you also have views on how we can address some biases, perhaps, or what gets overlooked when we're using some of these approaches.
I'll start. I think one of the challenges that we face is that the people developing the models, for entirely understandable reasons, come from particular backgrounds. So I don't necessarily mean their identity, whether it be gender or ethnicity, although there are biases there too, but also they come from particular educational backgrounds. Specifically, they tend to come, again for obvious reasons, from engineering or computer science backgrounds, and they tend to come from elite institutions. So the combination of those two characteristics means that you are going to design in a particular way, and you can see from the conversation that we're having today that so the point of the most extreme engineering mindset, elite engineering, kind of MIT mindset, has maybe passed as people have realized that there are limitations, particularly if ultimately what you're doing is you're designing a social technology whose impact, if it's going to be both profitable on the one hand and emancipatory on the other, needs to work for as many people as possible. And so I suppose the way this began was with people writing books about algorithmic bias 5 to 10 years ago, whether it be Race Against Technology or other books like that. But I think it's now shifted not simply from a critique to a new way of trying to do things. And in a way, large language models, which have their pros and cons as a method for understanding society, the big pro they have is the one that Sasha mentioned, which is they are of culture, as you've said, right? They are models that are generative out of humanity's corpus of culture that we've got out there. And that corpus, yes, is biased to a particular language and to particular people, but it might be less biased than the mindset of the people originally constructing the tools.
Yes, very much so. There's also, it's kind of very unevenly biased as well. The data that we collect, for example, Jakartan teenagers are very well represented on the internet, probably better than Welsh farmers. So it's a very uneven space indeed. And I think there is certain push happening with all sovereign AI right now. Definitely Chinese models, for example, work better for Chinese. English models obviously work better for English. Audio recognition, for example, works better for Spanish because of that there's less phonemes in Spanish. It's a very phonемically kind of compact and well-distributed language. So there's all this sort of things. And I think there's usually where there's a lot of dynamics going on. There's competitive dynamics between companies. There are competitive dynamics between countries. And wherever there's complex dynamics like that, we need institutions that will sort of push it towards the equilibrium that we want to be in. Which equilibrium we want to be in is a political question.
Very interesting. Thank you. And now let's talk about skills and how we're training the next generation of social scientists, including computational social scientists. We need people who can both ask good social science questions, but also be comfortable with working with large-scale data, code, and build models and use them. So, Ben, from your perspective, what needs to change or be done in general in how we train social scientists in order to ensure that this kind of computational approaches become more mainstream?
So I have been a social scientist for 25 years now, since I started grad school in 2000, and I would say that the big change is that initially you went into a particular discipline, and that discipline had a particular way of training you, and you got good at it, and you got good at publishing papers in that, and you might occasionally take a class in a related discipline. So if you're a political scientist, you might take a class in economics or sociology or psychology, maybe. And what has changed dramatically over the last 25 years is that us fusty, hidebound academics have been forced by our graduate students to open ourselves up to different ways for them to acquire the new skills that they want. So a lot of this is bottom up in terms of both age, I guess, position in the academy, as people have said, look, if I want to analyze this question, actually computer scientists have a really good way of looking at it, or epidemiologists have a really good way of looking at it. And so I think across the social sciences, you see that students want to take multiple different and complementary methods. So I find, even just in our master's program, which you are an excellent graduate of, thank you for succeeding, we now, traditionally students would either do a kind of qualitative route where they'd learn about case studies and comparative historical methods and maybe a bit of ethnography and archival research, or they would learn statistics and then they would learn causal inference and they would learn some matrix algebra and econometrics. And now a lot of students are saying, I want to do it all. I want to learn how to interview people. I want to learn how archives work. I want to understand the difference between ethnographic approaches to qualitative research and elite interviewing. And I want to learn causal inference. And I want to learn computational methods. I want to learn text analysis. I want to learn concept development. And we, as the people who ultimately have to train them, it's very challenging for us, right? Because for two reasons. Firstly, because we have to find a way of doing all of that within, well, traditionally one department. And secondly, because actually social scientists need to learn substance as well as method. And it can be very tempting for graduate students to say, oh, well, actually, I just want to learn all the methods so I can be really teched up. And that's great, except it's not so great if you never really learn the literature or the substance of a particular real-world problem that you care about. So there's that balance. So what we're doing at Oxford, what I'm leading, is this Centre for Advanced Social Science Methods I mentioned, or CASM. And you might think CASM is a gloomy name. I mean, it does, you know, chasms are not always great things. I think my colleague Ludwig told me that we should say that we're filling the void of social science or something as CASM. But it could have been worse because we've incorporated the Centre for Experimental Social Sciences, or CES. So there's always a worse acronym that one could have. But yeah, our plan is to hire 6 faculty to teach particular methods across the social sciences so that you have a hub. And you can see this with the London School of Economics. They have a methodology institute. I think that's probably the way that lots of universities will need to go, because otherwise you end up with every single department having 2 or 3 different computational social science courses and 2 or 3 econometrics courses and 2 or 3 qualitative methods courses. And yeah, at the very least, it would be wildly inefficient.
Mm-hmm. Very interesting. And just a quick follow-up question, just out of curiosity, Sasha, so you work at Google DeepMind. Do you hire many social scientists? Do you think there is like sufficient skill set that they are equipped with when they are, you know, interviewing for roles, etc.? What do you think is missing?
We don't hire many social scientists. We do hire some, but none in my group. But we do have a lot of neuroscientists. I think DeepMind was always taking up a lot of neuroscientists. But we are, specifically our project is very external facing, so we're trying to collaborate with many. I think the main thing that well, not worry, but is on my mind is the epistemic norms of different disciplines that we're sort of interacting with now, as the computational methods are really different now and are moving in. What's the epistemic norm? How is it changing? And that is also something you have to teach to students. And I mean, from computer science perspective, what was our epistemic norm when I did my PhD? Well, there's a paper somewhere. Your PhD, let's say, that's like the starting point of knowledge. Have a PhD student who can implement that in my code base. Well, then it's reproducible knowledge, and then I combine it with something, I write a new paper. If it gets through review process at NeurIPS, okay, new knowledge created. What if I now replace a student with a coding agent? I give it the PDF, it spits out the code. Is that knowledge reproduced or not? What if the agent wrote the paper as well? What if that starts flooding the system of peer review? What are we going to do then? And I imagine in social sciences there are similar questions that arise. And we kind of need to reevaluate all that and figure out what is actually knowledge. How do we agree on the new epistemic norms for all of this? And I think for the new, especially generation of social, like any pretty much scientist, we now have to be very open-minded about our methodologies, be a lot more broad, I guess, because I think one of the reasons the students want everything is because they think it's accessible now, right? I can get a deep research overview of this. I can ask an agent to code up that, and maybe that is the human niche, because we can cover the breadth. We also are embedded in the society, so we know what's important. We can be physically present in rooms like that and sort of get what is actually salient for the society. But I don't think I have good answers here. Yeah.
Very interesting. And Hannah, how are things at Cambridge? So you are obviously in a very cross-disciplinary space, but is there anything you think is missing, or maybe something that's being done really well?
Yeah, that's a really good question. So the way I see it is, when you have computational social science, to me, that's inherently a multidisciplinary field, right? So you need people from different places coming together, and if you want to create new skill sets, they all need to speak in this. But I have seen that people within computer science speak their own language, and people within social science speak their own language too. And we need a translator in between, because people get intimidated if they don't understand certain concepts. And if you're a computer scientist, there are certain words, they just make sense to you because you've been studying them for years. You have your own Bible where you just read all these words, and suddenly there's someone else coming and doesn't understand what you're saying. How do you make sure that all these concepts are translatable in a way where it actually works for people that want to go cross-disciplinary? And how do we make sure that that also works throughout time? Because all of these concepts, they constantly change. I wake up one morning and suddenly there's a new technology, something new again, and no one understands how it works, and we're supposed to teach the next generation. What are we going to teach them? So I remember when I did my master's, ChatGPT was not out yet, and I was looking at natural language processing. How do you build language technologies? And suddenly ChatGPT did come out, and they had to scratch all the lectures because suddenly there was this new technology. They still didn't know how it worked. You would go to conferences and people would be on stage saying, okay, here's a screenshot of what works, here's a screenshot of what doesn't work, but is that actually how you learn a new skill? And I think we have to make sure that everything that we create now stays up to date, because you don't want to sit in a lecture where you're talking about something that was new 10 years ago, but you don't need it now, because no one is going to care about that. And I think that's going to be the hardest thing to do, where you manage to be with the hype and with the current surroundings, and make sure that you actually translate your ideas, translate the skills, also on a global level, because not everyone has the same background, and everyone has a different definition of what society is. So if we want to look at social studies, then we have to make sure that we're not just looking at one particular society.
Yeah, very interesting. And now I'd like to talk a bit about real-world impact, which is, of course, something that the social science community cares a lot about, and we are always trying to do more and better on that front. Compared to other methodological traditions, is there anything where computational social science having the clearest edge when it comes to real-world impact? And I'd like to turn to all of you on the panel, and perhaps let's start with you, Ben.
Yeah, it's hard to know at this juncture in the social sciences what type of computational social science has had a huge amount of impact, because we're a few years behind the computing and engineering sciences. Generally, what policymakers like to see are flashy whiz-bang applications, so that that bodes well. but that doesn't mean that the data that we would be giving them would necessarily be helpful. What the impactful things in the social sciences are usually predictive applications, often geographical ones, that show you where some kind of problem is going to emerge. And so machine learning more generally, beyond large language models, has always been an effective way of refining the way that we predict where things are going to happen outside of the remit of the more standard linear models that we've been using for generations. So that has been an advantage, and you've seen that in all kinds of things, including tracking, using geolocation, tracking wartime deaths and wartime examples of various forms of atrocities. So people have used this to look at where you have gendered violence in war, or where you're seeing kidnappings, right? So that kind of analysis from the kind of foreign policy community is working. I suppose in my domain of sort of electoral politics and things, it hasn't been hugely impactful yet. I mentioned the example earlier of some colleagues who found ways to take social media to try and have a kind of always on poll, but it's not really a poll either. And it's hard for us to know ultimately what the value added sometimes is when the initial techniques of either polling, survey polling, or randomized controlled experiments still seem from a analytical perspective like the best way to figure out a solution to a social problem. So it might be the case that we can recreate randomized controlled trials through large language models, and indeed my colleague Tommaso Battistoni, he's been trying to do this, but so far the results have not been brilliant. Right? Getting your large language model to experience a treatment or a control and what happens yet isn't yet beating what we find when we actually randomize things in the real world. And I think this is to get to the point that my colleagues here have been making, this is where trying to figure out how to replicate a culture as a whole is a really hard challenge. So I would say we're probably on the cusp of impactful computational social science, but it's not been as impactful as one might have imagined yet.
Fascinating. And Sasha, may I turn to you now? How are things in industry?
Well, I would say it's hard. Like, I think I would second Ben's. Like, I think we haven't yet seen an impact of any sort of computational social science in industry, but there's a feeling that this is possible. I think the reflection of what you were describing in our world could be, well, we can create loads of synthetic users to test our software, right? This is like an obvious thing. And it works in certain cases to certain degrees, but a real user is still a lot better. And that is pretty clear, but maybe that's fine because you can also compensate with scale and speed if you have a synthetic protocol. So I think we're really, we're kind of, it looks like there should be something coming, but we don't know quite yet what it is.
Interesting. And Hannah, what about you?
I would say that the biggest impact is the fact that this field even exists, that something like this is possible, because for me, with my computer science background, I never would have imagined that I can actually work with humans and do something beyond just building something. And so to me, this has actually already been impactful, even though there's nothing out there specifically that will wow everyone. But for me, as a person that is trying to make sure that the technologies work, this has been hugely impactful, because now, as a computer scientist, even though I didn't study social sciences, I get to work together with social scientists. I get to dive into the literature. I get to use the methodologies and combine it with my expertise as well. And the research that I'm doing wouldn't have been possible for me like 10 years ago even, because then I wouldn't have been a computer scientist, right? Like the fact that I get to work with other people, or for example, the languages that I mentioned, like if you're working together with a language that is completely oral, you don't have an orthography, which means you have to work together with linguists, you have to work together with social scientists, you have to work together with so many different people. And I get to be a part of this project too, because we're using technologies. And that wouldn't have been as easy a few years ago. And I think the fact that we now approach these areas where we can allow for different disciplines to come together and maybe think of solutions that otherwise we wouldn't have thought of, to me, that is already a huge step towards a better, future. So to me, I don't actually care about the solutions that we come up with. I think it's also more important to think about the methodologies that we're using and the fact that we are finally accepting other voices in there. So yeah, to me, it's been great so far.
Yeah, very interesting. And so we have two perspectives that are more, we are on the cusp of something, and a more sort of practical, so this is what's actually happening, this is what it's changing. But when we're thinking about impact, what is it that's usually lacking? Is it the quality of insight? Is it the lack of some tools, or the lack of some vehicles such as, Ben, in your case, a policy unit, or perhaps a startup that can actually carry that something into the real world? So in your experience, what is the barrier? Why are we not perhaps seeing some impact as we should?
I think one of the things that's lacking is the epistemic norm, right? We can run a lot of simulations, but we just don't know how valid they are. And we can maybe validate them in some cases, but then we're still not sure how do they kind of generalize broader. Like any one of you can just take ChatGPT or whatever language model you prefer and go like, hey, like, what's the answer to this social science question? Then it will spit you something out. Would you trust that? No, right? And there's good reasons not to. So I think those kind of protocols for validating, but also knowing what it like of how to formulate the question, how to read the answer, and how to know that that answer is correct, and what it is, but also what does it mean for an answer to be correct, right? Because there's many ways an answer can be correct. And I think that is lacking more than anything else. I think we have the tools, and we're working on some tools, like we have an open source library that we published specifically for generative social simulations, but this is also one of the reasons we published it open source, and we're inviting everyone to sort of play around with it, is because we need the specialists in particular fields, whether it's economics, ecology, or social science, to actually figure out what are the epistemic norms in their fields while using this technology.
Thank you. Ben,
yeah, I mean, just as a quick aside on epistemic norms, I edit a journal, Comparative Political Studies, so kind of general political science journal. And a huge challenge for any computational paper, paper using computational methods, is it's not obvious that the work is replicable, because it's very hard to get an LLM to spit out the same thing every time. And it's not quite as simple as giving it what we would do in a standard probabilistic way of giving a random seed number, because it's much more complicated than that. So that is something that we're struggling with as a discipline, or indeed as social science disciplines. In terms of how could this work be more impactful, I think we also need to know what types of problems people wish to have solved. Now, it would be nice if politicians often say, oh, why don't social scientists resolve problems for us? And there are two responses to that, one of which is you all disagree on which the problem is to be resolved, so that's quite hard to know. And the second problem is that politicians don't understand how computational methods work, so they are essentially going to somebody dressed in a wizard's outfit saying cast some magic and hoping that things happen. So that is quite challenging, and I've had these conversations with politicians before, where I leave thinking, actually, it'd probably be a good idea if we didn't try and do what you wanted us to do, because you don't really know what you want, and you've imagined a technology that doesn't really exist. So I think there's actually a culture clash that's important for social scientists to get their head around about, well, okay, these are political decisions about what's important, but it's also not clear that politicians understand what these methods can do or how they work, and we can put as many Matt Cliffords as we want into government, but it doesn't necessarily mean that our cabinet ministers have any idea what's going on. So maybe what would be more useful is if government departments could indicate more clearly, perhaps through UKRI, what types of problems they think need to be resolved, and if they had some specialty there. But I do think there's a little bit of a disconnect between a world where we say, gosh, wouldn't it be great if computational methods could solve poverty in Britain or something, and the scale of the idea and what the technology can do are just totally incommensurate.
And,
so how would the answer look like?
Yeah,
right?
what answer do you want? But the thing is, they're saying, well, just cast me a spell and I'll know.
Yeah, exactly.
And actually, to your point, Ben, pretty much every single government department has published their areas of research interest, and they are inviting input from the academic community, and those are essentially the priority research questions that relevant government departments want to have answers to. And many of those answers, they already kind of exist. So it's also probably the question about communicating and bridging the gaps.
And I should just say, aligning academic career incentives with what the government wants. Because it's not obvious that academics benefit from studying those questions unless their own incentive structure is aligned towards that, which it typically is not.
Yes, no, this is a topic of a whole other conversation, which is fascinating. And just to conclude, I'd like to take a more sort of future-oriented look. What would you want a computational social science ecosystem to look like in, say, 5 years, in terms of the kinds of questions being asked, where work is happening, and how it shows up in the world? And in particular, if we look back from, say, 2030, what is it that we need to do today to then say that social science played the AI moment well? So what are your thoughts on this?
So I have two thoughts. One is that we have some way of kind of forecasting technological impact before the technology is deployed in a social impact way. So a good bad example is that we put out the social media basically as is without thinking much about it, and then basically did a lot of mental damage to people. I don't think that's a particularly controversial thing to say, especially younger people. There's enough evidence coming out of that, and if we sort of had at least some way of, like, rather than fixing the problem once we create it, we had at least some way of predicting that it could be a problem and going the other way. And then I think the second, which is sort of related, but I've been to a workshop in Cambridge with ecology folks, and they were very interested in sort of trying to move the social tipping point before the ecological tipping point. And I think it's a good way of thinking about more things than just the ecology, is that if we could find the way to sort of change the equilibrium of behavior before the problem, rather than as a response to something like, well, okay, our behavioral structure is just completely invalidated by the change in the environment, and we now have to adapt, and usually it's very costly and very damaging, that we can sort of maybe turn them around before that moment. That would be great. I mean, this is maybe a bit of science fiction for the next 5 years, but if we're there, that would be great.
Fantastic. Ben, what's your thoughts on that?
So I think it's really hard to project out 5 years when you're dealing with something where the technology is improving or changing, at least exponentially, right? And it would be a little like trying to figure out what the optimal lockdown strategy would have been in February of 2020. Right? We sort of saw that something was happening, but we don't know what. I think there's a kind of perversion of Malthus's problem. Sorry, I'm in the British Academy, but you've got to let me do this. You know, in Malthus's world, he was worried that population was increasing exponentially, but technology only improved linearly, and so that eventually you wouldn't be able to feed everybody, and then they die in all the horrible Malthusian ways. We have a different problem now, which is our technology is increasing exponentially. This gets to Sasha's point. And our ability to kind of counteract the negative effects of that technology doesn't appear to be increasing at the same rate, and indeed may only be increasing linearly. So how we deal with, you know, technology ultimately was faster than population growth under Malthus, but are there, I suppose, a little bit like the nuclear scientists of the 1950s with their concerns that our technological abilities had outrun our ability to survive as a species, we have a new version of that. And we didn't blow ourselves up then, so maybe we won't do the equivalent of that now. But I think that's the challenge that we need to be thinking about over the next 5 years.
Many challenges. Hannah, what about
I'll
yourself?
be quick. So I also wanted to say something about the question before, where, like, what can we do with the impact? I think, obviously, we talked about metrics as well, how to even measure impact. But I think one big thing is really money. Because, you know, we start building all these projects, but then there are grants and everything. And then you get to the point where you've collected all the data and you're getting to the point where you're deploying it, but there's no money left to actually measure the impact, to actually look what happens after you've deployed something. Like all that valuable data that we've collected, all that valuable, like the product that you have or like the thing that you build with the community, the money stops as soon as you've deployed it, as soon as the project is over. But how about, you know, creating projects that go into the phase where you're measuring impact as well, that the project doesn't stop when you put out something new. The project should never stop in my eyes, but obviously that wouldn't work with the money, but at least, you know, you can make a plan, okay, for the next few years or months, we'll look at the impact this technology has or this product. But also when it comes to the future, I would just like to say, can we all slow down a bit? Because we're building all these technologies and they're so fast and we're trying to be faster, you know, better, more efficient and so on, but we barely understand the technology. And that is coming from people that are calling themselves experts, right? Like they barely understand their own technology. So how is anyone else in society supposed to keep up with anything that's happening, right? And we're building this because we want, I don't know, more money, more fame, more hype. We don't know. But the thing is, like, there are so many people that are struggling to keep up, to even to stay alive in the first place, but then keep up with the technology, especially if this technology isn't built for them in the first place. And now, as soon as they figured this one thing out, there's already a new thing, but they don't even have the resources to figure this new thing out. And it's like, no, can we please just take a step back and think about, okay, how can we make sure this works for everyone? And also, we don't need to be this fast. Like, there's no point. Why are we trying to be so fast? So maybe, you know, slowing down.
I just love it when a question creates more questions than answers.
Sorry.
No, this is great. Do we have any audience questions? We have time for a few. Okay, a lady and a gentleman over here. We will take 2 questions and then we'll direct them to the panel. Oh, yes, please go first.
Thank you all for the inspiring talk. I'm Eva from London School of Economics. I'm first-year PhD student, so I'm interested about the LLM synthetic agents. So there's a lot of literature on the bias of these agents compared to human samples. So I'm curious about how we social scientists can contribute to the methodology instead of just consuming them, like the passive receptions of this methodology. So that's my question.
Mm-hmm. Who would like to take this one on the bias of agents?
Well, I imagine you tell me, right? So you're the social scientist. I'm the tool maker, and I would love to hear how you folks are thinking about it. And that's why I believe in open source software and talking to people. And that's exactly what I was I guess repeating myself over and over. We need epistemic norms, and they can't come from computer scientists because we have our own epistemic norms to deal with. But yeah, I think the constructing the validation protocols is the bread, and that's how we did in computer science forever. Like we just construct validation protocols, we convince everyone that they're good, and then we go with them. So we would love to hear the validation protocols you folks have for us, and we will implement them.
There's a really interesting paper that people at DeepMind have just written actually about AI agents, mostly AI economic agents, so in other words like high-speed trading and things like that, and about the regulatory challenges. And they talk about the concept of permeability. So to what degree are AI agents closed off from the rest of us? So if they're totally closed off, then they're an interesting social science experiment on a computer. If they're totally not closed off, then we don't know who's doing what and how it affects our lives. That question about permeability is the one that we need to think about. And the degree to which bias matters will also depend on the degree to which AI agents actually interact with us as humans.
Thank you. And we had one more question. The gentleman, yes, please.
Yeah, so this is a question about skills. So Sasha mentioned that we're going to have AI agents that write code and entire research process for us. But I wondered, like, what sort of counts as an epistemic contribution in the sense where, you know, AIs can do almost all the skills that we currently employ in our workflows. And I can imagine sort of two scenarios. One is that researchers guide, conceptualize, and steer these sort of AI processes in the sense that technical skills are still needed for AI governance and managing these types of tools in an extremely complex way that's going to maybe increase significantly in the next coming years. Or I can imagine a scenario where like soft skills are really important, so like emotional intelligence, interpersonal relationships, creativity, areas that the humanities deals with, like asking questions, philosophical questions. Which one of these directions do you see the necessary skills going to compete in today's technological environment, or tomorrow's technological environment?
I would say both. So I think there is no way, or like however good your agent is, there's no way around of telling it what you want, right? And you need to also understand the answer. So I'm using coding agents a lot. You got to explain to them what they're amazing, but if you don't tell them what you want, and to tell them what you want, you need to also understand the boundaries of possible. You need to roughly understand how computer architectures work, and then you need to be able to comprehend the answer and to know how to test that the answer is correct. And there's no way to do that without technical knowledge. And there was, I think, an experiment somewhere where they took graduate students from, students from different years, gave them LLM coding agents, computer science students, to measure how well they did. And the more senior students did better at using LLM tools. And the reason wasn't even that they used better terms or something, it was just like they kind of knew what you can ask of a computer, and they knew how to evaluate the answer. Well, but the soft skills and just being human is incredibly important because, well, we don't care for some possible words, we care for this one. And we're the ones who have to communicate that to the machines.
I think, if I might add something, I think one thing that we have to make sure that we still keep is obviously our critical thinking, that that you're able to evaluate and so on, but also what you're giving up when you suddenly you ask like an LLM to write the paper for you and so on, you just create something that is very mediocre, really, and you don't have any original ideas anymore because everything that you get on paper is just like a whole blob of words that comes from everything that we've trained it on, but where is the originality in it? So I think there you have to think about what is actually important to you. Do you want to have original ideas? And that's when you have to get back into it. Do you want to have your own voice, the way you write in it? Or should it just be like mediocre word dumping? So yeah, I think that's maybe an approach.
I would just conclude by saying it's one thing to engage in vibe coding, and I've done a little bit of that myself. And by the way, like most of the apps that I've created online involves me stealing some code from Stack Overflow, right? Yeah. So it's not that people weren't doing something like this. But I think there's a difference between that, where you know the output you want, and what I'm calling vibe modeling, where you say, oh, sort of come up with a model for how you think the world works, or come up with a bunch of machine learning algorithms or regressions that might work here. I think there's a real danger there that we're outsourcing how are these concepts supposed to connect to one another, and ultimately what is the object of interest we're trying to study, and what are the assumptions we're making when we're doing that. If you just say, oh, come up with a model, then you have abrogated your responsibility for the choices ultimately that the model is making. And I think that would be bad social science.
This is a fantastic point to end on, and this brings our panel to a close. 3 thank yous. First of all, to our panelists, thank you so much for sharing your expertise with all of us. Then to the organizers and to everyone here in the audience, thank you so much for your interest in this topic. And now I believe we have a coffee break upstairs. So thank you very much for joining us today.